welcome back to my channel. So the next topic in field theory is charge density. So what is this charge density is? So like in the previous videos and all, we have seen vector addition, right? Vector addition. Vector addition is possible. It is used to determine the field intensity at any point. So if you want to know field intensity at any point in a field, okay, field intensity, you can know this by when these electric charges are isolated from each other. Here these charges are isolated from each other. Charges are isolated. Okay. Then you can find the field intensity by vector addition. This is what we have seen in the previous videos and all, how to add these vectors and all. Okay. But here in charge density, what happens is when these charges which are isolated, these are kept in some volume. Charges are kept in some volume. Kept in some volume in the sense some area, some smaller area. Okay, suppose if you're considering this is the area, this is the volume. Okay, now you're placing these charges. That means the distance among these charges is the distance r is very less. Okay, so when this that means extremely small. Okay, the distance is very small. Because of that, the charges will be no longer considered as isolated charges. So these are not isolated. Okay, these are in connection with each other. Okay, so this charge will be when it is continuously distributed in the volume, then it is considered as volume charge density. Okay, this is called volume charge density. All right. So previously, when the charges are isolated from each other, you can, by doing vector addition, you can know the field intensity. Here, when these charges are kept in some volume, that means in some smaller area, see the distance between them is very less. The force of attraction or repulsion, anything can happen in this. That means all these charges are linked with each other. So that is called as volume charge density. Okay, so if you consider the charge as Q, okay, charge as Q, and which is uniformly and continuously distributed throughout the volume, through the volume V. So volume is given by cubic meters, okay, cubic meters. So you can call this volume charge density as volume charge density is defined as charge per unit volume. Charge per unit volume. That means this charge density, this is the definition. Okay, so that means this charge density is given by the symbol rho V. Charge per unit volume. Charge is written by the letter Q per unit volume V. So this is called charge density. Okay, rho V is equal to Q by V, and charge units are coulomb. Okay, and volume is cubic meter. So it can also be written as like this. Okay, rho V is Q by V. Now further explanation of this is, this expression is actually for when the charge is uniformly distributed. This is charge is uniform. Q is uniform. All right. When it is not in uniform, that means this charge per unit volume, this will be varying. Varying in the sense you can keep it as delta. Okay. When the distribution of charge is varying or not uniform. Okay. Sorry, not uniform. You can say that as in the volume rho V is given as limit delta V tends to 0. So that is delta Q by V. By delta V. Okay. So delta Q is the small charge, and this is the small volume. Small volume. Okay, the smaller the volume it is, the more accurate the value of charge density is obtained. The lesser this value is, the accurate you can get the charge density value. All right, this is when the charge distribution is not uniform. Okay, now we'll see what is meant by surface charge density. It is nothing but, by the name itself, it is surface charge density. That means if it is uniform and the charge is continuous over the surface area, then the amount of charge per unit area of that surface is called as surface charge density. First point is it should be uniform. I mean the charge should be uniform and it should be continuously distributed. Continuous distribution, okay, over a surface. Over a surface. Then the definition we have, right, for volume charge density, charge per unit volume. Similarly here, so when it is over a surface, then the amount of charge per unit area of surface, so that is called as surface charge density. Surface charge density. There for volume charge density, we said volume charge density, right? So there the amount of charge per unit volume of the volume, okay. Here it is nothing but surface, okay. So this can be written as, there it is rho v, right? Here it will be rho s. Rho s is equal to q by s. There it was volume, that's why this was v and this was v. Same thing for surface is the thing. So if it is this is uniform, right? If it is non-uniform, same like the previous one, rho s is equal to limit delta s tends to 0, delta q by delta s. That's all. Non-uniform. Non-uniform charge, okay. So for this also the units is cubic centimeter square, okay. Now we'll see what is meant by linear charge density. This is surface, that was volume, and next one is linear charge density. In simple terms, here you can just remember this as linear means it is some length, okay. So you can call it as charge per unit length. Simple meaning, that is charge per unit length, okay. So if q is the charge, q is charge, and consider L as the length, okay. So then you can tell linear charge density is written by rho L q by L for uniform distribution of charge, or rho L is equal to limit delta L tends to 0, delta q by delta L. So this is also another definition of linear charge density, okay. So in a clear little more understanding, if you consider a long conductor, okay, which is in the form of a rod or any wire, the cross sectional area of it is very, very small when compared to the length, okay. So that charge distribution along the conductor may be assumed as linear charge distribution. Suppose if you are taking a conductor or some kind of a wire, okay, so this is the conductor. So the cross sectional area, the area of this one is very small when compared to the length. This is the length, right? And this is the if you consider the area, this is, so this, then the charge is uniformly distributed along this conductor, okay. So that means this charge, when it is uniformly distributed, then that is called as linear charge density, or in simple way, this depends upon the length, so charge per unit length. So this is the derivation, okay. So we have seen like surface, linear and volume, okay. I'll just briefly write and show you for clear little more understanding. So first we did that is volume charge, okay. Next one was a surface charge, I mean all densities, okay, densities. And next is this one, linear charge density, all right. So for this the formula was rho v is equal to q by v. This one is rho s is equal to q by s. For this one, rho L length is equal to q by L. So for non-uniform, you can just apply limits for this one. I think this is clear. Charge density for volume, for surface and for linear. Okay, this is clear. So this is one of the little important topic after electric field intensity. I think this is clear. If you have any doubts, please let me know in the comment section. If you haven't subscribed to my channel, please do subscribe to my channel, because there are a lot more videos coming in this subject, field theory, which is very, very difficult for a lot of students, and I'm here to help you out. Thank you.